polynomial functions are continuous everywhere on their domain. So if you have some type of polynomial where you got those coefficient numbers in front of variables to different degrees or powers, those are always going to be continuous everywhere. So example of that would be like the function 7x to the 5th minus 10x cubed plus 2x squared plus 19. That's a polynomial. That would be continuous everywhere. You could plug any number in for x, and so we know they're going to be continuous. Rational functions, which we've also looked at in the past, are also continuous everywhere except where you don't have numbers in the domain. And we know with rational functions, those are where the denominator will end up being 0. So wherever q of x equals 0, those places it would not be continuous. So it's discontinuous where q of x would equal 0. All the other places, this is a polynomial, this is a polynomial, so it's continuous all those other places except where that bottom may equal 0. So let's look at some functions, see if we can determine if they're continuous at certain points or where they're discontinuous. It says use the definition of continuity, show that the function shown here is continuous at a equals 3. Well, if we want to show it's continuous, then plug in values and see. Remember, we're trying to show that limit here as x approaches our a value, which here is 3, of this function equals the function at 3. To figure out the function at 3, that's just plugging the number 3 in here. So if we want to find f of 3, all we're doing is substituting in 3 here for all the x's and seeing what this gives us. Well, that's 9 plus 7 minus 3 is 4, square root of 4 is 2, 2 plus 9 is 11. So now we got to check if this is 11, is the limit as we approach this the same thing? Well, this limit, I don't think we have to do anything fancy with this one. It's just limit of this same function. And there's nothing wrong with us plugging 3 in here. And basically it's just substitution. We should get that this side also equals 11. Well, if they're the same thing, yes, then this one is continuous. Find where this function is discontinuous. And also they want to know where is the function continuous. So discontinuous, we're checking. Is there any places, top, bottom function that would not be continuous? Now the top is not a polynomial, it's a natural log function. So where do we know natural log is not continuous? If you graph out the natural log function, you are going to see a graph that looks something like this. Okay, so it is a continuous function, but notice it stops here. There's an asymptote on the y-axis, and there's no values on this side of the graph. And so we know for this part, the domain is that x has to be bigger, something bigger than 0. If you plug in 0 or a negative number, not going to work. What about what's the domain of the bottom here? The domain of the bottom, I think we're probably going to want to do some factoring there. It is a polynomial, but it's a polynomial we can factor. That would factor to x plus 1 times x minus 1. So what are the two values here where this is going to equal 0? Because we can't have division by 0. Where we put these equal to 0 and solve them, we get x equals -1 and x equals 1. And so the domain of this bottom is all the x's where x can't equal those two values. And so where is it discontinuous? It would be those places where we just listed where you can't plug in those numbers. So we would say this one is discontinuous where x is less than or equal to 0, because that's not going to work with our function there, and at x equals -1 and x equals 1. All those places is discontinuous. We can't put those numbers in there. Where is this function continuous? All the places in the domain. So this would be continuous from, we can't include 0, but anything slightly bigger than 0 up to, now because we got to say bigger than 0, I don't think we're ever going to go through that point, but we are going to go through 1 here. So 0 to 1 union 1 to infinity. It should be continuous everywhere there. If we try putting in 1, it's not going to work because we get division by 0. If we try putting anything smaller than 0 or smaller in there, we're not going to be able to do it because the top function doesn't work out.